this lecture, I'll be talking about a structural query language or SQL script. So far, we learned different data structures that we could use them to store data. For example, a dictionary that maps keys to values, and we could use that to save information in a tabular format. A dictionary is limited to the size of the memory in the computer. That's why we use databases to organize data. Most databases are organized like a dictionary in the sense that they map from keys to values. However, a database is stored on permanent storage, and it can store far more data than a dictionary. In a relational database, data is stored in tables. As you can see here, each table consists of columns and rows. Each column is an attribute, and each row represents one tuple or record. When we say how many records we have, we are referring to the number of rows. So tables are equivalent to relations. Columns and attributes are the same, and rows and tuples are the same as well. Each table has a primary key. It's like a unique identifier for each record. Often a singular unique attribute or ID number. It also could be multiple attributes. SQL is commonly used database language, and there are two main types: data definition language and data manipulation language. Under data definition language, we define a schema for each relation or table, domain of values associated with each attribute. So we will talk about different domain types in a minute. There are also constraints, and we will discuss them. After we define tables and relations, then we are able to query information, and that's the data manipulation language. We can insert, delete, and update tuples. There are two Python libraries, SQL Lit3 and SQL Alchemy, which allow us to run SQL commands from our Python notebook. In order to be able to work with those libraries, let's review SQL basics and its script first. A SQL relation or table is defined using the create table command. So here you can see the syntax. Create table R, and then A sub 1, D sub 1 through A sub n and D sub n, and then we have n integrity constraints. In this syntax, R is the name of the relation, your table. It can be like table a student, table customers, and anything else. Each A sub I is an attribute name in the schema of relation R. In other words, there are columns in the table. And D sub I is the data type of values in the domain of attribute A sub I. What kind of data can be accepted in that for that attribute? In this slide, you can see domain types in SQL. Character of n. It's a fixed length character string with user specified length n. We can also have varchar of n, which is a variable length character string with user specified maximum length. The other data type is integer, which is a finite subset of integer that is machine dependent. The other data type in SQL is a small integer, which is a machine-dependent subset of the integer domain type. As you can expect, real or double precision is another domain type, which is floating point and double precision floating point number with machine-dependent precision. And float of n represent floating point number with user-specified precision of at least n digits. We also have integrity constraint. In order to define the table, we need to specify the integrity constraint. So integrity constraints guard against accidental damage to the database by ensuring that authorized changes to the database do not result in a loss of data. Here you can see three main integrity constraints. The first one is not null. It means that the value for that attribute cannot be null. The other integrity constraint is primary key. Primary key lists attributes that comprise the primary key or the unique identifier for each table. And the foreign key, A sub A, references R. So the foreign key lists the attributes that comprise the foreign key and the name of relations referenced by the foreign key. So we use the concept of foreign keys to link different tables and relations. By default, a foreign key references the primary key attribute of other tables. And you are going to see an example here. So we have two tables, sales order header and currency rate. So for the first table, sales order ID is the primary key, and then you can see the different attributes or columns. And one of the columns, currency rate ID, is actually the primary key of currency rate table. So foreign keys are used to link two tables together. And foreign key is the key that is primary key in another table. When we create the table, we can drop, delete, or alter the table. If we drop a table, it deletes table R and its content. It completely deletes it. If we delete from table, it deletes all contents of table R but keeps table. And we can alter the table R, and add attribute with their domain. So alter table adds attribute A with domain D to table R. We can also alter table R and drop A if we want to drop a specific attribute or column. Moving on to data manipulation language, we are able to query information and insert, select, and update records. Insert a statement. You can see the syntax here. Insert into R, referring to relation or table, A sub 1 through A sub n, and values. And you can see the select a statement. So we select attributes A sub 1 through A sub n from R sub 1, R sub 2 through R sub n. So we select these attributes from these tables or relations. SQL is structured similar to English language. The basic command for receiving data from a database table is to select data from a table. So the keywords select and from make up the core of a SQL statement, as you can see here. Sometimes we want to retrieve only a subset of the data. And in such cases, we use where keyword, as you can see here. Condition represent how we want to filter the data. Now let's look at an example when we want to apply the select statement and condition to multiple tables. So multiple tables are often used in database, and here you can see an example. Consider a table customer, person ID, the data type or domain type is integer, and that's the primary key for this table. There are 3 attributes or column: first name, a string; last name, a string; and age, an integer number. And consider another table named orders. Order ID is the primary key and its type is integer. There are 3 attributes here, as you can see: order quantity, which is float; order price, double; and person ID, which happens to be the primary key in table customer. And so it's the foreign key and its type is integer. Now we want to find the last name of all customers who have ordered something more than $100. So we are going to use the select, from, and where statement when we have 2 tables connected through a foreign key. So we select last name, we are looking for last names from these 2 relations or tables, customers and order. And then after the where keyword, we add the condition. Where customers.person ID is equal to orders.person ID and order price is greater than 100. So that's how we can query information from 2 tables, which are connected through a foreign key. SQL has built-in mathematical functions as well, which allow us to perform mathematical operations on the data. Common functions include sum, average, mean, max, and count. So here is an example. We still see select from where, and then we see a new keyword, group by. To allow SQL to correctly calculate what we want, we need to use the group by keyword. It means that apply this function for each department. Here you can see the syntax. Attributes in select clause outside of aggregate function must appear in group by list. So we select department, average salaries as mean salaries from employees table, where then you have the condition, years of employment is greater than 2, group by department. It means that calculate this for each department. Previously, we talked about using the where keyword to filter result. We cannot use where to filter based on the result of a function. In this case, the filtering condition based on the function need to be specified after the group by phrase, and having is used to filter based on the result of a function, and you can see here. So if you want a predicate based on aggregation functions, use the keyword having. So select department, again average salaries, from the same table, employees, group by department, having average salaries greater than 42K. So we will need the having keyword in this case. So with that, we wrap up our discussion about the basics of SQL.